which is Charles' law. Charles, in 1787, worked out a relationship between the volume of a fixed mass of a gas and its temperature by keeping pressure constant. You know, in the case of Boyle's law, we kept temperature constant, and in the case of Charles' law, Charles kept pressure constant, and he now relates volume and temperature. And this is what Charles says. According to Charles, in his law, that the volume of a fixed mass of a gas is directly proportional to its temperature at constant pressure. Now, mathematically, let's look at that law mathematically. So we have V varies directly with T when P and N is kept constant. The N here is the number of moles, while our P is our pressure, this temperature, and then this volume. If we remove this sign of proportionality, we have V is equal to KT. All right? However, let's call this equation 2. Remember, we have equation 1. We are using equation 1, 2, and so on because we are going to use it in calculations. Okay. Now, looking at this, V is equal to KT. We can divide both sides by T so as to make K the subject of the formula. So we have V all over T is equal to K. All right? And if that is true, we can still have V1 all over T1 is equal to V2 all over T2. All right? Now, with this formula, we can calculate for volume as well as the temperature when pressure and number of moles of that very gas is kept constant. All right. Graphically, let's represent Charles' law. So we have this, and then we have this. That's a plot. So here we have V, and then here we have T. So at any given point, if V increases, T will also increase. At least, if the volume of the gas increases, the temperature will also increase. And if the temperature of the gas increases, there will be an expansion of volume or an increase in the volume. All right. At this point, I'm going to combine Charles' law and gas law to come up with another equation we will call the general gas equation. So, from Boyle's law, we have it that V varies inversely with P, all right, which we call equation 1. If you can still remember. Then recall also that from Charles' law, we have V varying directly with T. And I remember we call this equation 2. Now, in any point here, T is kept constant, so I can say multiply by T. And while here, P is kept what? Constant. Multiply by P. It's kept constant. This is constant. This is constant. All right? Okay. Now, if I do away with this, the sign of proportionality, I'm going to have here V is equal to K over P, right? While in equation 2, we are going to have V is equal to KT. In any case, we also have this as PV is equal to K, all right? And then we also have this as V all over T is equal to K, our constant. Now, if we consider these two, this is common here, this is also common. So I can have PV, which is this, all over what? All over T is equal to our common K. K is common there, which is a constant. All right? Now, if we have PV all over T, then this will translate to P1 V1 all over T1 is equal to P2 V2 all over T2. And I'm going to call this equation 3. So our equation 3 is what we call the general gas equation. So here we can calculate for P1 V1 T1 or P2 V2 T2 as the case may be. So the only thing that is not here is our number of moles. So we have 3 parameters. So we can calculate for these 3 parameters in any case when asked. All right. Hope you are understanding what I'm saying. Good. This is very simple. Now, we will look at the next law. That is number 3, which is the Avogadro's law. Avogadro's law. Okay. Now, Avogadro's law states that equal volume of all gases under the same temperature and pressure contain the same number of molecules or number of moles. And mathematically, we have it that V varies directly with N, where our P and T are kept constant. So that's the mathematical expression of the Avogadro's law. So V varies directly with N, okay, where P and T are kept constant. Now, I want to call this equation 4. Okay. Now, if I combine equation 1, so combining equation 1, 2, and 4, let's see what we are going to come out with. So equation 1 says V varies inversely proportional with P. That's 1. And then 2 says V varies directly with T, which is Charles' law. All right? And then equation 4, which is Avogadro's law, we have V varying directly with what? N. So look at this. So can we say at this point that V varies directly with NT all over P? So combining equation 1, 2, and 3, we have this. V varies directly with NT all over P. All right? Now, if I remove this sign of proportionality and introduce another constant, I'm going to have V is equal to arrow into NT all over P, where the arrow here stands for gas constant. The arrow there is a gas constant. A gas constant. All right? Okay. If I open my bracket and then evaluate that, let's see what we are going to come up with. We are going to have V, all right? Now we're going to have PV, that's PV, is equal to N, arrow, and T. So I call this equation 5. Equation 5. Our equation 5 is known as the ideal gas equation. Ideal gas equation. Ideal gas equation. I want you to take note of all these equations because we are going to use this equation to solve problems. So now we have equation 1, 2, 3, 4, as well as equation 5.